Hello, very good afternoon, everyone. We are in the 12th lecture of this coursework named Geotechnical Engineering 2. I hope you all are doing well. This is the coursework which is designed for the 12th week, but as I have planned the one additional class, as this class is going on every Saturday from 3 to 5, but I have planned one additional class, so I am taking this extra class over here, and in the scheduled class which is going to take place on Saturday from 3 to 5, I will take the revision of the entire sessions which I have taken from first to 13th, 12th class, so that you will get a better idea of understanding of the things which we have gone across from starting to end. And if you have any query, I can also try to answer them all. Okay, so that's my viewpoint regarding this course. So I think so this coursework up to that will be helpful, as this is the concluding session. If it is the 12-week course only, but I always try to take one additional class in which I take the revision of the entire session and try to pinpoint some specific point which may be useful during your examination which you gave during your certification course examination. So that's my thinking process regarding the course. So I hope that will be helpful. So this is the additional session, as there are the very less attendance over here during this class, so that not the query for me, but as it is the working day, so if you are going through the YouTube, you go through the lecture and you get benefited from that. Okay. So first of all, starting with introduction, my name is Sumit Kumar. I am PhD research scholar at IITS in Dhanbad. And this course work named Geotechnical Engineering 2, taught by Professor D.N. Singh sir from IIT Bombay. And over here, we are reading the practical implementation of the thing which we have gone across. Our the soil mechanics course or the geotechnical engineering course, whichever you have gone across at your academic sessions, whatever the name they benefited. But over there, we have understand the basic concepts. Over there, we will exploring the advanced concept in which we have understand the shear strength concept of shear strength, different tests which we perform to get the shear strength, and what are the benefits, advantage, disadvantage regarding the same. Okay. Before going to that, I have some instruction regarding this today's session as well, and instruction is very simple. That this session going to take place for 2 hours. That is, they started at 12:30, so we'll go till 2:30. Over there, we are discussing the concept which are taught in the class. We will solve some problems and see that develop understanding about the subject. Apart from that, during this session, whatever the presentation I am presenting will be shared with you through the Google Drive link, which will be shared by with you by the NPTEL team itself. And if any other query required, you can ask the question over here at the end of the session. I will suggest that will be better for me as well as for you, that the link will not be broken. You can note down the your problem and ask in one go. Apart from that, the video which I am presenting over here, those who are in the live session or those who are not, and they can see this video on the YouTube, which will be shared by me by the end of the day today only. So all those things will be there. Apart from that, if due to any problem, due to any network connections, if I get offline due to any reason, please be remain in the meeting. I will rejoin and start the class from there only. If some time get lost, not to worry. I will compensate that in today's session only. That's not the issue. Okay, so now we can go with the content. So the content which we have studied till date are the shear strength, different aspects of that. Apart from that, we have understood the earth pressure, we have understood the seed piles, and in the last class we have take the little bit glimpse of slope stability, which we are going to carry forward today. And apart from that, after the conceptual clarity, we will take some question as well, in which we solve the very good problem specifically asked in the many good examinations. Specifically, I am taking the question from either from the books or maybe from the competitive exam, so that you will get the better idea of the implementation of those problems. And the competitive exam also, I carry only the GET or engineering services, so that the question will of very good quality. Okay. See, so we are studying the slope stability, and we have understood that why we need a understanding of the slope stability. So slope stability, why the slope stability is so much important for us? The first question is that only when we start the subject. Over there we say that it has been found that if we consider our country only, it has a wide variety of terrain. We have a place, we have a plateau, we have a mountains, we have a desert, we have a wide variety of aspects across the mainland of India only. So over here, as we have found specifically in the Himalayan range, the states which are situated in the Himalayan range, over there it is found that the failure of slope is a major problem. If we see Sikkim, if we say Himachal, so over there the many slope failure will result in the loss of life as well as property. So as a civil engineer, as a geotechnical expert, we need to understand the slopes. If we get develop understanding of slope, afterwards only we could able to provide a mitigation technique by which we can reduce the chances of failure, as the nature always try to prevent us from any damage. But if the human activity surpasses at a certain extent at any place, it could may also lead to a chance of slow failure. But in general, also during the rainy season, we found that the failure of slope has been observed on the obvious basis. So those things need to be eradicated, and those eradications process require a better understanding of the slopes. If we understand the slope, we understand the different type of slope, the failure associated with slope. Afterwards, only the mitigation technique could be suggested. So we as a civil engineer have a responsibility to do so. That's why we are taking this course and understanding the slopes. Afterwards, we could provide the mitigation from the problem associated with the same. Thank you. Okay. I think so. We have gone across some basic understanding, the basic definition in the slope stability. Over here, we will carry forward those concepts. We see some definition, we see some interrelation by which we could found how much the safe our slope at the present condition, what are the different conditions associated for the infinite and finite slopes. We have seen up to certain extent like Taylor stability number things. We have take the little glimpse of that in the previous class on the which takes place on the last Saturday. We carry forward that in this class, and as this class concludes, in the next class I will take the revision in which I have approximately 200 slides which we take very quickly in the 2 hour session so that the overall revision could be there. Okay. So first of all, starting with the slopes. So slopes are the inclined surface that are found naturally or created by humans. As we have seen, we have said in the previous class that due to doing the construction by cutting or filling or by construction of any canals or maybe embankment sections, over there some slopes may be created. So the failure could be takes place at those cross sections so that are created by humans. But in general, if you have visit any hilly region, specific in hill station, over there you see the mountains are there, the hills are there, and over there some slopes are present on which the people also try to climb. So those slopes are created naturally, and normally the natural slopes are the infinite in nature. Basically, they have a specific inclination, as we have read in the previous class. Also, over there, the beta we have implemented that make with the horizontal axis the inclination of the slope and the surface associated with the base, which is inclined at specific angle beta, maybe 10 degree, 15 degree. So that surface is the sloping surface. The slope could be finite, slope could be infinite. How they are related is in the understanding you must develop from the last class only. Now the slope stability, when you go in definition, so the slope stability is the ability of slope to resist a failure. Slope failure can occur when the forces driving instability exceed the force resisting the instability. Obviously, if the a force is applied which tends to move the soil drawdown through the slopes is more than the resisting force, then the slope gets faced. If the resisting force which try to protect that specific cross section is more, then it is no chance that the slope get faced. And when we go move further, we say that the slope failure can be very destructive, causing the loss of life, damage to property, and disruption to the infrastructure. When we talk about the slope geometry, So the angle of the slope, the height of the slope, and the shape of the slope can all affect the stability in one way or not. Soil and rock property. The properties of the soil and rocks are very much important. As we go ahead and we see some interrelation regarding the factor of safety for the infinite slopes. We are found over there that the infinite slopes behave differently at different soil property. Over there, we also see the effect of water table as well. As I have said many times that the water is the biggest enemy of the soil in one way or the other. If the water table is not there, the 50 to 60% of the problem associated with soil get eliminated. So those aspects we also take into the our study as we go ahead. Okay, so the strength of the soil or the rock, the type of the soil or the rock, and the moisture content, what I ever said regarding the water table as well of the soil and the rock can also affect the stability. The presence of the groundwater and the flow of the groundwater can all affect the stability of the soil and could reduce the factor of safety at a specific cross section as well when we see these things under consideration going ahead. Okay, now the other thing which we have read from the very childhood, we have read from the childhood that the forestation, if the vegetation is there, chances of soil erosion get reduced. Right. This thing we have read from the fifth or sixth class, or maybe second or third standard only. So over there, we see that the grass tree bound the soil with it and reduces the chances of movement of soil from there. During the flood, also we say if the vegetation is widespread over there, the flood water does not take the soil from that cross section. So those things we have read from very initial conditions. Similarly, that takes place with the slope as well. As the vegetation can help to stabilize the slope by providing root of reinforcement and reducing erosion. As these vegetation act as a reinforcement for the soil and try to resist their movement along the slope and ultimately reduces the chances of failure. When we talk about the human activities such as the construction, excavation, deforestation can also affect the slope stability. As you see from the image over here, it is clearly viewable that the many construction takes place along the slopy ground as we go from upper section to lower section. Over there, the slope need to be stabilized, and the vegetation is also clearly visible at the specific cross section. So, these vegetation could, one way help to bound the soil, create a bond between the soil to soil intersection, so that they could reduce the chances of failure. Now, as we see, the many landslides takes place. So the landslides are the most common type of slope failure. Specifically during the rainy season, we have seen the several news articles and the news presenter are saying that over there the slope failure takes place. The road is abandoned. There is no movement possible through the roadway between this city to that city. So that takes place due to the landslides takes along that. As in the hilly region, the any construction of the roadways or the railways there, they are constructed by cutting the mountains and making the road over there. And at those cross section, maybe upper or the lower cross section, the vegetations are there. The mountains with a huge amount of soil mass at a specific sloping angle are there. As the rain takes place, the result in the increase in the water level at those sections, resulting in the reduction of the effective stress due to increase of pore water pressure could lead to the failure as the shear strength at those sections get reduced as the effective shear stress sigma dash is equal to sigma minus u, where sigma is the total stress, u is the pore water pressure get increased, sigma dash get reduced, resulting in the reduction in the strength. So the failure of slope takes place. Now we talk about the next concept, that is the rock fall. So this is the type of the slope failure that occur when the individual rock or the boulder fall from a slope. Yes, this is the individual rock section. As we have seen, normally this is not takes place, but at some sections the large piece of rock material may be there which could fall from their initial position could lead to a type of failure. So the fall of the rock is along maybe boulder or the large size of soil mass accumulated together, which may be stated as the rock, is also a type of slope failure. Now we came to understand a new word, that is debris flow. Debris flows are the type of slope failure that occur when a mixture of soil, rock, and water flows down a slope. So this is called said to be debris flow. The next one is the mud flow. Mud flow are the type of debris flow that is primarily composed of mud. It must be possible there a case in which the soil are very small particles, so that if the waters along with that flow along the slope and resulting in the failure, it look like the flow of mud through that specific rock section. So that is the mud flow, right? Yes. See, now see the next concept which we are coming with. Over here, you see, we talk about the limit equilibrium method. There are the some method which we used during our analysis. So limit equilibrium is a method that are the most common type of slope stability analysis. If we perform the different analysis like the strength reduction method to calculate the safety, over there also the limit equilibrium is employed. In the limit equilibrium, we try to find the safety as well. Over there, the summation of force, summation of moment, we assume to be zero, and on the basis of that, we perform our calculation to get a specific result, right? Now, as we are seeing the another method whose named is the finite element method, that are also one of the sophisticated type of the slope stability analysis method, in which we divide the slope in the small units, small elements. Over there the analysis are performed on each of the element, and afterwards, so what are the implementation takes place due to the different conditions which are present over the site, we are able to found the outcome associated with the same, and report our result for the practical observation. Now, one more thing which we needed to understand while reading the slope, that the drainage. So drainage along the slope need to be improved, because if not so, the slope stability reduction, reducing the amount of the, if the drainage condition is better, over there the accumulation of water will be less. If the accumulation of water will be less, resulting in the reduction in the chance of failure along the slope. When we talk about the retaining wall can help to support the slope and prevent the failure. And when we talk about the buttress, so buttress are the masses of the soil or the rock that are added to the base of the slope to provide the support at the base of the slope. The failure chance could be there, so that will be reduced with the by the help of implementing the buttress. And as I have said earlier many times, also it has been found that we have read that vegetation help to stabilize the slope by providing the root reinforcement and reducing erosion in a way. Now we talk about the some of the specific sections which we should look into before going into the detail of the slope stabilization, and those are the words like the slope geometry, soil and the rock properties, the groundwater presence, the vegetation across the cross section, the activity of human, the landslides, rock fall, debris flows, mud flows, and these definitions associated with all these we have seen already in the previous slides. Okay, now we have came across the limit equilibrium method, finite element method. We understand the drainage, we understand the retaining wall, we understand the buttress and the vegetation, as well as their importance in order to provide a stability to our slope at the specific sites. Now we go into some detail about the stability of slopes, which with the theoretical understanding. Up to that, we are studying the philosophy regarding the slope. Over here, we see the mathematics regarding the slope, so that you get a better understanding about the thing which we are discussing, how mathematically we can implement those things. We will see one by one. So these are the things which we are going to see. That first of all we see the definition, then the types of slope. Afterwards the cause of failure of slope, then the pattern like the base, face, and toe failure. Then the what are the aim behind the establishing the slope and the different type of factor of safety, what are associated and how we are able to find. We will see. Then going ahead, we see the type of slope failure. Afterwards, the stability analysis like the infinite and finite slope. We look into that. Then the Taylor stability number and the method of preventing the slope failure are the aspects with which we end up the to this sections. As then we move to the section in which the different questions are present which we are going to solve today to lead to a better understanding of the concept associated with this. Now, first of all, starting with the definition. So a surface of which one end or the side is at higher level than another, a rising or a falling surface, both are considered as slope, and a slope can be defined as an inclined body between the ground and the air. It is also said that an earth slope is inclined or unsupported part of a soil mass. And as you see over here from the figure, the natural slopes are presented. Slope present in the hilly area is the natural slope. As you see, some of these ranges, I will take a pen or the highlighter. Um, okay, over here you can see this section. This section you can see over there. So this is the section which is presenting the natural slopes. Okay, it is already existing by nature, not created by us. So these cross sections, the slope exist in the hilly region, are the natural slopes which are created by nature only during the with the establishment of the earth form. Right. Now, as we have also see the formation of the soil particle, how the uh, earth get formed, how the shape of the globe which look today get formed, how the Eurasia and many more things, how our planet system gets separated, how tectonic plates get settled one over another, why the Himalayan mountain is called young mountain, how why it is raising year by some inches. So everything we have read during the basic understanding, or maybe the you have gone across the ground improvement technique or the advanced soil mechanics. Over there also we have seen. Now, when we talk about the man-made slopes, so the slides are cutting the slopes of the embankment construction for the road, railways, canals, etc. And the slope of the earth dam are constructed for storing water as well. And over here, the some of the figure also presented the same is shown in which the catch water drain, cutting, carriage, everything has been presented. The embankment which is created to resist the flow of soil or water is shown, and then in the next subsequent picture, their cross section is also presented. Now we talk about the slope. Now we talk about the slope, whether natural or artificial, may be infinite or finite, as it has been of debatable topic earlier. When we have not the better understanding, we feel that all the natural slopes are infinite and all the man-made slopes are finite, but that not always the case. As we know that the infinite slope, the term infinite slope is used to disinject a constant slope of the infinite extent. This is the long slope of a face of a mountain, as we have also presented in the previous picture which we have seen. Now, when we talk about the finite slope, so the finite slopes are of the limited extent, and the slope of the embankment and the earth dams are the example of the finite slopes. Right. Now see the cause of failure of slopes. There must be some reason, and this is not the case. if a specific things which are created by nature or maybe man-made could fail due to the certain reason, there is no possibility that sorry, without a region, a specific slope gets filled. So first is the gravitational forces, the second is the force due to the seepage of water, the subsequent one is the erosion of the surface of the slopes due to flowing water, and going ahead the sudden lowering of water adjacent to a slope could also lead to the failure, and then the forces due to earthquake is one of the major reasons could lead to the failure of slope. As we are talking, if we talk about our country only, the most of the Himalayan range lie in the zone 5. So over there, the chances of the failure under the earthquake are enormous high. So it needed to be develop a better understanding regarding the slope and their behavior under the different conditions, like as the lowering of water table after the rainy season or due to the flow of water along the slope due to poor drainage, or the force due to seepage water, specifically again in the rainy season, are some of the factor in addition to the earthquake forces. So if we get the better understanding, their mitigation is also suggested by us, is found to be of in order. Now over here, see the pattern of the slope failure. The first one is showing the rotational landslide. Over there, the failure pattern is clearly visible. Over here, if you see along the cross section from the right side, if see over here, specific at this cross section, how the failure takes place, a arc has been created, is presenting. That's why it is said the rotational landslides. Is a subsequent one, the translational landslides is there. In the translational landslides, the failure takes place along the length only without affecting too much. Over here, you see the cross section. Over here, is the height at this section is something, at this section is other, and over here the flow takes place. Similarly, in this process, the translation landslides look like that. Then we see the block slide. In a block slide, the whole soil mass which is present eh, at this point move along the length and get situated at the next point. It move like a block only. That why it is called the block slide. Then the rock fall which we have gone over there, when the rock fall, mud flow, the different definition we came across, we have seen the rock fall definition is there, in which we have said the large part of the rock or the boulder get falls from a specific section. So this rock fall is also viable. In a topple is one of the pattern of failure which is present in the subsequent one. Then the debris flow, the definition we have came across, is also presented. Then the debris avalanches, okay, avalanches means if you talk in Hindi, tufan. So that types of things also takes place around the mountainous region. The earth flow, the creep, these are the some of the patterns associated with the failure of slope is visible in these images. Now see, as we have understood the slopes, the patterns, their failures, now we came to understand the aim of the slope stability analysis. So the aim is to assess the stabilities of slope under the short term, often during the construction, and the long term condition, to assess the possibility of the landslides involving the natural or the existing engineering slopes. So, to analyze the landslides and to understand the failure mechanism and the influence of the environmental factors are the some of the apps. Going ahead to enable and to enable the redesign of the fed slope and planning the design of the preventive and the remedial measure where necessary to study the effect of the seismic loading on slopes and the embankment are the some of the aim associated with the slope stability. Now, the question is there that what causes slope to fail? Sorry. Okay. Now see. Now we have a new question with us that what causes slope to fail? So the failure of slope or the soil along the slope must occur along a plane or the curved surface when a large mass of soil slides with respect to remaining mass. In other words, we can say that there is a downward and outward movement of the soil takes place in a case of the slope failure. So, in this regard, we could say that the slope failure occurs when the forces causing the failure are greater than the shearing resistance. Shearing resistance is nothing but the shear strength that developed along the critical surface of failure. As I have said very many times, and during our shear strength lecture, which takes place in the second or third lecture of this series only, over there I have given an example that the soil must have a specific strength. If it fails from the specific section, this must be chances that the strength along that section is minimal. That's why failure takes place from there only. Otherwise, the failure could take place from anywhere along the cross section of the soil. So the strength over there of with the soil is shear strength, and the stress which is applied due to the presence of the soil mass above each, which may be acted just along with surcharge. So that is the stress which is applied. So in this condition, if the resisting force are less than the driving force, would result in the failure of the slope along the critical surface, and the critical surface is the one along which the strength of the soil is minimal, that is the shear strength of the soil is minimal. Now, the factors which lead to the slope failure could be divided into two types. First one is that the factor which causes the increase in the shear stress, and the second one is the factor which causes the decrease in the shear strength. If the shear strength get reduced, the failure takes place. If the shear stress get increased, then also failure takes place, because the shear stress is the applied stress which is acting along the critical section, and the shear strength is the strength at the specific section along the critical cross section. Now, when we see that regarding the slope stability, to calculate the factor of safety, we say in the slope stability, the analysis we determine the factor of safety the ratio of resisting force to driving force. So factor of safety is said to be resisting force by driving force. And over here, theoretically, we could say that any slope with a factor of safety less than 1 will fail, and any slope with the factor of safety greater than 1 will not fail. And this is the very much simple understanding, as if the resisting force is greater than the driving force, in that case the failure could not take place, and if the resisting force is less than driving force, over there the failure takes place. Though the statement which is mentioned over here state the same. Now the design focuses on the soil parameter and the geometry that will provide the maximum factor of safety, because as a design engineers we are keen to provide the best safety measures which could be provided at the during the analysis. Now we see the slope stability. So sometimes the analysis of an existing slope will be what is called the parametric study, that is establishing a factor of safety and performing an analysis that back calculates the strength parameter, and the an engineer will then determine his her confidence level as to whether or not the soil has that much strength through the experience, lab, and the field data. So over there, we could perform some analysis. We could see as a case study of the pre-existing slopes which are already stable to state a specific section, or which may not be stable. So what are the regions? On the basis of that, we could incorporate some of the things to stabilize a similar slope or the same slope based on the experiences associated with the other slope cross section, right? I think so, right? Now Now we see in the types of factor of safety. We have said during our starting of this section only, a different type of factor of safety could be there. We are going to discuss. Afterwards, the tail stability number is also into the line which we are going to read, in which we read the term of mobilized cohesion and how we are able to find the factor of safety, and mobilized cohesion could be stated. Right. See, the factor of safety with respect to shear strength is defined as the ratio of available shear strength to the mobilized shear strength. So the factor of safety is said as tau by tau m, where tau is the available shear strength and tau m is the mobilized shear strength. Similarly, for when we talk about the factor of safety with respect to cohesion, is defined as a ratio of available cohesion to the mobilized cohesion, that is C by Cm. And as we go ahead, we talk about the safety with respect to friction is defined as a ratio of available friction to the mobilized friction. So Fi is said as phi upon phi m, or sometimes also said to be tan phi upon tan phi m, at phi value may be small. That's why it has written like that. Now we talk about the types of failure associated with the slope. So as it is shown over here in the first, the soil at of high strength, over there the phase failure takes place. In the homogeneous soil, the failure which takes place is said to be toe failure, and when the soil, softer soil are present below the toe sections, so over there the base failure takes place. So in this fashion, the slope failure, toe failure, and the base failure could take place. When we talk about the slope failure, the phase failure also is said to be stated, as we have seen earlier in the, specifically in the last class on Saturday. Over there we have seen that how much the strength is the less below along the slope, so the soil of high strength, over there the failure takes place along the face only. So the face failure, or the failure which is stated over here as the slope failure, took place in this fashion. Now some assumptions are also there when we go ahead with this concept. So the assumption is that the stress system is assumed to be two-dimensional, and stress in the third direction are taken as zero. The Coulomb equation is used for determining the shear strength. That is, shear strength is nothing but C plus sigma tan phi, where C is the cohesion, phi is the angle of internal friction of the soil. Now, it is assumed that the seepage condition and the water level are known, and the pore water pressure can be estimated. As the seepage condition and water level are already known to us, so the pore water pressure calculation is not much difficult for the investigators, and the shear strength at all the points are enough to mobilize all the available shear strength. And when you talk about the stability analysis of the finite slope, over there we say for the cohesionless soil, like in the dry state, the factor of safety of the infinite slope for the dry state may be written as Fs equal to tan phi by tan I, and for the submerged state it is written as the tan phi by tan phi only. But when the steady flow conditions are there, then the tan phi by tan I, where the phi is the angle of internal friction, I is the inclination of the slope with the horizontal for the infinite slope. But when the seepage along the slope takes place, then the factor of gamma dash by gamma set also came into fashion along with tan phi by tan beta or tan phi by tan I. And in this case, when we found that factor of reduced approximately by half when the steady state takes place along the slope with respect to the factor of safety, which is calculated for the submerged condition in the same fashion as over there, the gamma dash and gamma dash at the top of the equation and bottom of the equation get eliminated, but over here that doesn't takes place with the steady CP along the slope condition. Now some of the calculation is also mentioned over here, like which are related to the 10 5 by 10 5 I. So that's when we say about the purely cohesive soil, whatever we have seen for the cohesionless soil. When we talk about the cohesive soil, the factor C also came into fashion. And for the dry state in the infinite slope, we again say C by gamma cos I sin I into H. Similarly, for the submerged case, it is said by C by gamma dash cos I sin I into H. And when we move for the STD over there, the STD seepage condition over there, the C by gamma set is only because the seepage takes place, so the water table is above, so the condition is saturated in the same condition. Now, when we talk about the cohesive frictional soil over there, the value of C and phi is both present at that cross section. When we write for the dry state, we say Fs equal to C plus gamma h cos square beta cos square I tan phi by gamma h cos I sin I. Similarly, for the submerged condition, the gamma change to gamma dash in above and below interrelation for the same. But when we move for the steady seepage along the slope over there, as it which is stated earlier for the positionless while gamma dash by gamma set. Similarly, over here as well, those relation is said as gamma dash by gamma set only for the steady seepage along the slope. Okay. Now we talk about the stability analysis of the finite slope. As we have also seen during the previous session, the friction circle method, Swedish circle method. So over here we see what are the things which we are looking ahead. So the some of the methods which are used for the stability of the finite slopes are the wedge failure method, then the friction circle method, after about the Swedish circle method, which is also said to be method of slices, then the things which are performed with the Swedish circle method are the analysis of the purely cohesive soil, that is phi equal to 0, and analysis of the C5 soil as well. When we see the wedge failure method over here, a wedge failure occurs when a soil deposit has a specific plane of weakness and the stratified deposit generally fails along the interface. The figure shown a soil mass resting on the inclined layer of the impermeable soil. There is a tendency of the upper mass to slide downward along the plane of the contact AB, and as it presented in the figure, it is clearly visible that the thing which is stated is followed. Now, the forces trying to cause the sliding is tangential component of the weight W along the plane of the contact as it is visible. So T is nothing but W sine alpha as T is visible along the slope, that is going to be W sine alpha as alpha is making the angle with the horizontal, and alpha is the making plane AB makes with horizontal, and the force tending to resist the sliding depend upon the cohesion C, and a frictional force is given by S equal to C into L plus W cos alpha tan phi, where L is the length of the failure surface. So the factor of safety is given as C into L plus W cos alpha into tan phi upon the W sin alpha, which is the nothing but the tangential component of the weight along the plane of contact, which we perform for the wedge failure method. Right. Now we move to the friction circle method. As we have seen over here that the wedge failure method, friction circle method, Swedish circle method. So the wedge failure method is understanding is developed by us. Now we move for the friction circle method. So in the friction circle method is based on the fact that the resulting reaction between the two portions of the soil mass into which the tri-slip circle divided the slope with a tangential or a concentric smaller circle of radius r sin phi. Since this is also the question asked many times that what is the radius of that circle, so r sin phi will be the answer for the friction circle method. So the r sin phi, because since the oblique duty of the resultant at the failure is the angle of the internal friction phi. This of course implies the assumption that the friction is mobilized in full, and the smaller circle is called to be the friction circle or the phi circle. The forces acting on the slide wedges are first is the W weight of the wedge, W of the wedge soil. Second one is the reaction due to the frictional resistance, and then cohesive force CM mobilized along the slip surface as it is visible from the friction circle method concept of the friction circle over there. The radius is clearly visible as r sin phi, and the CM equal to the mobilized cohesion is also shown. So the forces in the sliding wedge is visible with the W, the CM, and the R is variable. When we talk about the friction circle method only, in which the procedure which is gone ahead is looked over here. So first they consider the slope as shown in the figure. Over there, the crest of the slope is said as B and the toe of slope as A. Now draw a tri-slip surface arc AC passing through the toe, that is A, with O as a center and R as a radius. So over here you see we have AB. Now we draw a arc AC which pass through the toe, and see the radius of that is found to be R, and the center of rotation is also found out. Now the tri-slip surface is found. Now find the concerned centroid of the sliding soil mass A, B, C, A, and calculates its weight W. Right. Now the force triangle gets formed in which the W is acting in the downward direction, C is acting in the lateral direction to that, and P is acting perpendicular to C. Now let the slip circle to be considered to made up of the number of elementary arcs, each of length delta L. This is discussed in the last class in more detail, but over here we are taking a guess the glimpse of that. So let the cohesive force acting along this element opposing the sliding soil be Cm into delta L. So over here the total cohesive force along the arc AC forms a force polygon. Also, the closing side AC of the polygon represent the magnitude and the direction of the resultant cohesive forces. Now, when we move for the same step regarding this calculation only, over here see, let the length of the chord AC be LC and the length of the arc ACB L. Now the magnitude of the resultant force C equal to Cm into LC. The position of the resultant can be obtained using the Varigo theorem, which is stated as over here. The calculation are mentioned here with. Now on mobilization of the frictional resistance, let P be the soil reaction opposing the sliding of the soil mass as shown, and the reaction due to the frictional resistance is P is inclined at an angle theta to the normal at the point of action as shown. So in this over here, by knowing the magnitude and the direction of the W and the direction and line of action of the other forces, the force triangle can be completed. Measuring the magnitude of the C, the FOS can be computed as shown, and the mobilized cohesion CM is said to be C upon LC, and factor of safety with respect to factor of safety with respect to cohesion is given by FC equal to C by Cm, and the minimum factor of safety can be obtained by locating the critical slip circle. So the founding the critical slip circle is the first criteria while moving with this method. Now we move to the Swedish circle method, but before that we will take a small 5 minute break, right? And afterwards we came with the Swedish circle method. So the 5 minute break will be there. Hello, hello, hello. Okay, hello, hello. Am I audible? Hello. Yes. Hmm. Okay. So we'll start from as before going to break. We are discussing about the different type of method which is used to calculate the factor of safety for the finite slope. So we'll carry forward that concepts only, and we move to the Swedish circle method, and we will go ahead one by one with all the method which we are keen to discuss during this session. And afterwards, we will move to the some of the problem associated with the same and see how far we can go with how much question we can cover. The question we could able to cover will be covered in this session. If something remained, we could cover in the next session, but that I don't think so required. But if required, that's not the issue. I will try to cover in the next session after taking the small recap of the entire session which we have came across till now. So let's see what is the best possible thing which we are looking with this coursework, and as we proceeded, how much things get changes or how much thing updatation needed by our side, right? Okay, so we are talking about the Swedish circle method. So this method was developed by the Swedish engineer assuming a failure surface to be an arc of a circle. And the two cases are considered for the same. First is the analysis for the purely cohesive soil. That is, in that section, we assume that the angle of internal friction of the soil to be zero, and the second is the C5 soil. In which the cohesion and angle of internal friction both are there, so that the soil is not purely clay, not nor purely sandy, neither purely clay nor purely sand. Right. So over here we see the some of the images and its explanation will be seen in the subsequent slides. So you can see from here that the total stress analysis for the purely cohesive soil is presented, and the arc length which L is presented as L equal to R theta, as we know that length of the arc for a specific theta angle arc, the length of the arc is said to be R theta, so which is presented here, and L multiplied by C is also presented as C. Okay, we will see. So starting with each with this in this method, number of trial slip circle are considered, and the factor of safety for each is worked out. The circle corresponding to the minimum factor of safety is called critical slip circle. So over here, let's assume that ED be a trial slip circle with R as a radius, as shown in the previous picture, which I have shown in the previous slide. R as a radius and O as the center of rotation. So let W be the weight of the wedge and A be D acting through its centroid. Now, for this section only, the driving moment is said to be W into E. Now, let us assume Cu be the unit cohesion and L be the length of the slip arc. So, AD is equal to 2 pi R into delta upon 360. Hence, the shear resistance developed along the slip surface will be equal to Cu into L, which acts at the radial distance R from O, which is clearly visible from this slide. Right. Now, when we talk about the resisting moment, so the resisting moment is nothing but Cu into L into R. Yes, and the F is nothing. F, that is the factor of safety, that is the resisting moment by driving moment. So we calculate Cu into L dash into R upon driving moment W into E. So now let Cm equal to mobilize shear resistance necessary to keep the equilibrium. So the W into D equal to Cm into L dash into R. Therefore, Cm equal to W into L dash into R. Hence, F equal to Cu upon Cm, that is equal to Cu into L dash into R upon W into E. Now, when we do the analysis of the cohesive friction soil, as we up to there we are looking into only cohesive soil phi equal to 0. Now we see the take our discussion further for the C5 soil. So over here we see the in order to test the stability of the slope for a cohesive frictional soil, that is the C5 soil, the trial slip circle is drawn and the material, give me a minute, and the material uh, in the material above the assumed slip circle is divided into the convenient number of vertical strips or slices as is shown in the figure as we go ahead, and the forces between the slices are neglected and each slice is assumed to act independently as a column of solid of unit thickness and of width b, as it is presented over here. 1 2 3 4 5 every section is presented, and the height at the middle section is taken, the area of the entire strip is taken, and the area multiplied by gamma is found to be weight and multiplied by height, resulting in its kilonewton per meter uh, force which is acting. So over here again those things are written as well. As for this calculation, the W of each slice is assumed to act its center, and if the weight of each slice is resolved into the normal direction, that is n, and the tangential component t, the normal component will pass through the center of rotation O. Hence, do not cause any dividing moment on the slice. However, a tangential component T causing a driving moment, that is Md equal to T multiplied by R, and when we do that calculation we are able to find our results as where the R in the above equation which we have discussed just above is the radius of the slip circle, the tangential component of a few slices, the base of may cause the resisting moment, in that causes T is a considered negative. Now the C is the unit cohesion and delta L is the curved length of each slice. Then the resisting forces from the Coulomb equation is equal to C into delta L plus N into tan phi, and a number of the trial slip circle are chosen and the factor of safety of the each is computed. The slip circle which gives the minimum factor of safety is the critical slip circle. Now, for the entire slip circle, AB we have the driving moment MD equal to R into summation of T. Resisting moment MR is equal to R into C into summation of L plus tan phi multiplied by summation of N, where N is the normal and T is the tangential. Okay, over here written as with the summation of T, the algebraic sum of the tangential component of the weight of the slices, and the summation of N is the algebraic sum of the normal component of the weight of the slices, and the summation of L is nothing but the length of the slip surface AB, which is calculated as 2 pi r into delta by 360 degree. It is nothing but r into delta only, and when we convert radian into radian, it found to be this, and hence the factor of safety against the sliding is the resisting moment by driving moment, that is nothing but C into L plus summation of N into tan phi or tan phi into summation of N upon summation of T, where summation of N again is the algebraic sum of normal component and summation of T is the algebraic sum of tangential component of the weight of the slices only, right? Now you see one of the example in which the not the question is given but calculation mechanism is presented. So first method, in which the first of all the value of W need to be calculated, and for that the summation of N Subsequently, summation of n and summation of t may be found by tabulating the value for the slices as indicated below. First of all, we divide the slice, we find the area, and as we find the area, we multiply by gamma, we find the weight, and when we find the weight, we find the weight of the slices by getting its normal and tangential component. So the summation of and summation of t is also found. Now, for when we imply the method 2, the summation of n and summation of t may also be obtained graphically. Vertical line drawn through the center of the gravity of the slice and the intersecting top and bottom surface of the slices may be assumed to represent the weight of the slice, and this may resolve graphically into the normal and the tangential component. These components for all the slices plotted separately as ordinates on the two horizontal baselines, and the plotted points are joined by the smooth curve as shown in the figure. They are called N curve and T curve respectively. Over here it is visible, but the previous method is more easy and mostly used as it is found. So the area under these curves represents summation of n and summation of t respectively. So the area under these curve measured by the planimeter and multiplied by the unit weight of the soil, which I have already said, to find the summation of n and summation of t. But this method is not so too much popular as I see. The previous method, the method 1, which I have said, is the best method for these calculations. Now we see the method 3. These methods are also simplified rectangular plot method, which has been suggested by Singh 1962 to determine the summation of n and summation of t. In this method, the end ordinate of each of the slices is assumed to represent as the weight of the slice, and it is resolved into the normal and the tangential component. Then we are able to perform our analysis. Right. Okay, so give me a minute. I need to take some water. Yes. Okay. So what I am talking about? We have talked about the different methods associated with the infinite and finite slopes. We are in that section only. Now we are moving to the Taylor stability number. What does it means? And what is its use? How it would be helpful in calculating the mobility factors as we go ahead, right? So we are talking about the Taylor stability number. So the slope angle, height, slope angle which is represented over here as I, height of the embankment as the effective unit weight of the material gamma, the angle of internal friction phi, and the unit cohesion C are known. The factor of safety may be determined, and as a Taylor in 1937 conceived the idea of analyzing the stability of a large number of slopes through a wide range of slope angle and the angle of internal friction, and then representing the result by an abstract number which is called as a stability number. This number is designated as Sn, which is found as C by gamma h into Fs or C by Fc into gamma h. That's not the difference thing. Over C is the cohesion, gamma is the unit weight of soil depending upon the soil condition. H is the height of the slope and Fc is nothing but the factor of safety. As you can see, the graph is also presented for the same for the beta n and many more things that the Taylor stability number phi equal to 0 case it provided by Taylor 1937 paper only, and the Taylor stability number for the circle passing through the 2 and below or above the different graph is also presented. Now the methods, some of the method which could be employed to prevent the slope failure consist of following. First one is the vibroflow flotation. In vibroflotation, How? By implementing a specific mm, section, we try to prevent the failure. And the second one is by providing the berm at toe, so the cementing of the toe and the berm landfill sliding along the embankment foundation is also be able. The third one is vegetation, as we discussed. Vegetation is one of the most and one of the basic things. If we provide that in good manner, it reduces the chances of failure. And the next one is the provision of the seed pile. We have read the seed pile at many times. Bulkheads in which the seed piles are provided in the bulk to resist the failure along the slope as well. We have seen during our study of the seed pile. So over here that example is also presented. Apart from that, that are also used in the water resistant structures, but over here also their implementation are quite viable. Right. Now we are moved to some of the questions. The questions which we are discussing over here is are of the MCQ nature. Afterwards, some subsequently we have some good problem associated with the slope stability of the standard books, or maybe the competitive exam are there in the subsequent slide. But what are the what is the speed with which we want to go? With that, we see that how much we could cover in this class. But if not so, I will cover in the without any problem. Right? Okay. So first question is here. So see the what is the question? Okay. Okay. So this is the question. Question say that which of the following factor does not significantly affect the slope stability? The options are slope angle, weathering, soil type, altitude. So the slope angle is the most important factor which affect, because if we calculate the factor of safety for infinite slope only, we say in a dry condition also we say factor of safety is tan phi by tan beta, where phi is the angle of internal friction which depend on the soil type, tan beta where beta is the angle of the slope which made with the horizontal, so the soil angle and soil type get eliminated. Okay, I will take a pen. Give me a minute. Okay, so the slope angle could not be answered, right? The soil type could also not be answered. Why? Because Fs for the dry soil in an infinite slope only also equal to tan phi by tan beta. Phi is associated with the soil type and beta is associated with the slope angle. So these two options get eliminated. Now the weathering and altitude. Oh, sorry. Okay, due to weathering, the property of soil also get affected. So this also could not be answered. So our correct answer is going to be altitude, which is option number D. Right? Yes. Now the next question is which of these slope failure characterized by a rapid drawdown movement of a mass of soil or rock? Which okay, rapid drawdown. So whether it is slump, creep, slide, or flow. I think so. Flow. Sorry, slide. Okay, slide is there. I have not revised it, so maybe I am get confused a little bit. Slides, if it is slides, so it's okay, no problem. Now the next question is which of the following is not a common cause of slope instability? Okay, not a common cause. First is the heavy rainfall. It is a cause. Vegetative cover. It is also a cause if the vegetative cover get removed. This could be happen human activity, it's also cause seismic activity, it's also a cause. But over here, as per option suggest, the vegetative cover is the correct answer. Because the question had asked that which of the following is not a common cause of slope failure. So the vegetative cover is a correct answer over here. Now the next problem asks that what method is commonly used for the slope stability analysis in the geotechnical engineering? So, as I have remembered, weather forecasting is not the method which is used for the slope stability. Limit equilibrium is the option, correct? The magnetic response imaging is also not a correct answer. Traffic simulation is never be a correct answer. So this is a very easy question which anyone can answer that the option A, option B is the correct answer, right? Over here we see that that solution also came. Now the next question say which type of slope stabilization method involving the use of the structural barrier to resist the pressure of the soil behind them. So the drainage system, soilless, retaining walls, grout. So over here the retaining wall is the correct answer as I see from the options very much clearly. I think so there will be no doubt in this question. No? Which type of the slope stabilization method involve the use of the structural barrier to resist the pressure behind the soil behind them. So the retaining wall is the one in which this takes place. Okay. Yes. Now we move to the next problem, which came over here, which state that which of the following factors can trigger the slope failure by increasing the pore water pressure. Vegetative growth. Due to vegetative growth, whether slope failure takes place due to increase of the pore water pressure. Reduction, reduced rainfall, seismic activity, temperature fluctuation. Whereas seismic activity is there, and due to which the increase in the pore water takes place could lead to the trigger of the slope failure by increase in the pore water pressure. Now the next question is what is the primary reason for performing the geotechnical investigation in the slope stability analysis? What is the primary reason for performing the geotechnical investigation in the what is the primary reason for performing the geotechnical investigation in the slope stability analysis? First is to increase the project cost. Give me a minute. Okay, so the first is to increase the cost of project. No, why we want to increase the cost of the project? And next one is to meet the regulatory requirement. It is also wrong. And next one is to delay the project timeline. Why? Why anyone want to do so? To access the soil and the rock properties. Actually, if we do the soil investigation, we are able to access the soil and rock properties. So this is the correct answer, right? Yes. Now, which of the following slope stability method involves the reinforcing the soil with the grouted element? So, terracing, gabion walls, soil nailing, or the rock bolting. So, as the option suggests, only the soil nailing is going to be correct answer to provide a type of reinforcing soil with the grouted element. Over here, this option only is the correct option, right? So, this option C is going to be our correct answer. Now, as we go ahead, we see the next question coming over here, which asks that which type of slope failure involve the gradual drawdown movement of the soil or the rock. It's asking the gradual. So the flow, slide, creep, and fall. Earlier we also see the options over there. I have answered the one of the problem, but over here the question is the gradual, and the gradual is nothing but creep. Right? Yes. Okay. Give me a minute. Right. Okay. So what I am asking that are you okay with the to this problem? I think so. Yes. Okay. So now we are moved to our next problem, which say that what is the recommendation approach for preventing the slope instability due to the heavy rainfall? Options are increasing the slope angle. This is option B is implementing the proper drainage system. Third one is removing the all vegetation, and the next one is adding the more soil to the slope. So the recommendation approach for preventing the slope instability due to heavy rain. Increasing the slope angle is not the correct answer. Implementing the proper drainage is the correct answer. So over here again, when we take the pen, we say the increasing the slope is not correct. Implementing proper drainage system is correct. Removing all vegetation is not correct. Adding more soil to the slope is not correct. So the option number B is the correct answer. Right over here you can see. Now the next question say at which slope software is commonly used for the slope stability analysis? Microsoft Word. No, in the Microsoft Word we have nothing regarding the slope stability analysis. The in MATLAB we can do up to a extent, but over here that is also not the correct answer. Over here the option C is the correct answer, that is most commonly used, that is the slope by W. Right? Yes. About Photoshop is also not used for that purpose. So option number C only is the correct answer. Now the next question is the what is the primary purpose of the slope stability analysis? To increase the construction cost? No. The next one is to delay the timeline of the project? No. To ensure the safety of the structure, right? To reduce the complexity of the engineering project. To ensure the safety of the structure is the correct answer. Option C is the correct answer. Now, as we go ahead, we see the next question which state that what is the primary function of a retaining wall in slope stabilization? So option A is to increase the water flow, option B is to promote the erosion, option C is to resist the soil pressure, and option D is to amplify the seismic activity. So over here we see uh, primary function of retaining wall in slope stabilization to increase the water flow, to promote the erosion, to resist the soil pressure, to amplify the seismic activity. So over here, the option C is the correct answer. Our option C is going to be our correct answer, right? Now the question say which type of slope failure involves the sudden movement of a mass of soil or rock along a along a well well-defined surface. Which type of soil failure involves the sudden movement of a mass of soil or rock along a well-defined surface? The option A is creep, option B is flow, option C is fall, and option D is slide. So over here, the option D slide is the correct answer. Now we move to our next problem, which state that which of the following is not a factor that affect the slope stability. So the options are the rock type, Um, Human activity, vegetative cover, atmospheric pressure. So rock type, on rock type it will depend, but it will not depend on not depend only on the atmospheric pressure. So atmospheric pressure is the correct answer. Okay. Now our next problem is that the what type of slope stabilization method involve the use of the plant roots to reinforce the soil, grouting, soil laying, bioengineering, rock bolting. So the bioengineering is the correct answer. Next one is that what is the primary cause of slope instability due to the human activity? Option A is the vegetative growth, soil erosion, excavation, atmospheric pressure changes. So excavation is the major region that causes the slope instability which involve the human activity. Now the question says which of the following is not a type of slope failure? So the fluke, slump, creep or landslide. So option C, that is creep, is the correct answer. Now as you move ahead 1 point ahead in a question, the question states that what type of slope failure involves the movement of unconsolidated material as a fluid. So the options are slump, flow, creep, or fall. So it is saying unconsolidated material as a fluid. So the flow is going to be our correct answer. Now, and the question next that asks what is the recommended approach for preventing the slope instability due to seismic activity? What is the recommended approach for preventing the slope instability due to seismic activity? First one is increasing the slope angle. Second one is decreasing the water flow. Third one is implementing the soil laying. And the fourth one is removing the vegetation cover. So only correct answer which I could see that is option C. Right. Now I will show some more question as well as time is still left. Okay. So I will show some more question before ending of the session. Okay. So what I am thinking, give me a minute, I will add some questions over here so that before concluding I can take those questions. Okay. So we are here before we have stopped for a small 1 minute session. Okay. Again, some questions are there. That what which of the following are not a factor that can affect the slope stability? The options are the slope geometry, Soil and rock property, groundwater, vegetation, and temperature. So over at temperature is the correct answer. Okay. Now when we move to the next problem, the question is that which of the following is the most common type of slope failure? So first one is the landslide, second one is the rock fall, third one is the debris flow, and fourth one is the mud flow. So it is asking most common. So landslide is the most common when we have go across our presentation. In this session only, I have clearly stated once that the landslide is the most common type of slope failure which takes place along the slope. The next question said that the limit equilibrium method are the most common type of the slope stability analysis method because they are easy to use, accurate. So they are easy to use and accurate as well. So the option C is going to be our correct answer. And when we see the next problem, which state that the which of the following is not a slope stabilization method. So the drainage, retaining wall, buttress, vegetation, all of the above are the slope stabilization method. So as you see, we provide the vegetation in good manner, buttress, retaining wall, drainage is accurate. So everything is perfect for the slope stabilization up to extent. That's why option E that all of above is the correct answer. Now, the next question states that which of the following is the most effective way to improve the stability of the slope? So option A say reduce the slope angle. Option B increase the shear strength of the soil. Option C reduce the groundwater level. And option D all of above. So question say which of the following is the most effective way to improve the slope stability? Most effective way reduce the slope angle, increase the shear strength of the soil, reduce the groundwater level, all of the above. If the slope angle is less, the chances of failure is less. If the shear strength of soil is less, the chances of failure will be less because resisting force will be more. If the groundwater is below, the chance of failure is reduced as well. So all of above is our correct answer for the this given problem. Now see, the next question states that the vegetation can help in stabilizing the slope by providing the root reinforcement, reducing erosion, both A and B, neither A and B. So both A and B is the correct answer because if we provide the root reinforcement, in this session only we have said that the reinforcement act as a root in stabilizing the slope, right? So that is only visible over here. Now, so the both A and B are the correct answer. The subsequent question is that which of the following is not a good practical practice for improving the slope stability? First, say that building on steep slope. Yes, not a good practice for improving the slope stability. Building on steep slopes, deforesting slopes, excavating slope, all of them are the bad practice for improving the slope stability. Specifically, if deforestation will do perform along the slopes surface, so the chance of slope will increase. Excavation is the major cause. So all of above is the correct answer for this question. Our next question state what is the difference between the landslide and the rock fall. So as we know that the landslide is a mass movement of soil, rock and debris that the slides down a slope, while in a rock fall is a type of landslide that involves the fall of the individual rock or the boulder from a slope. Similarly, when we talk about the debris flow, that what is a debris flow? We have stated its definition in this session only. So, a debris flow is the type of landslide that is primarily composed of the soil, rock, and water. Debris flows are often characterized by the high speed and destructive power. Now, the next question is about the mud flow, which asks that what is mud flow? As you know, in a mud flow, we have said that the soil along with water, which is muddy, flow along the slope during the failure is a mud flow. But when we see the definition in a true sense, it's state type of debris flow that is primarily composed of mud, which has a major component as mud. And the mud flow are often triggered by the heavy rainfall or the snow melt. The heavy rainfall is one of the major reason, one of the major aspects during which the flow takes place during the failure across the slope. Right. Now, the next question is that what is the purpose of slope stability analysis? So, the answer for this question says that the purpose of slope stability analysis to use to evaluate the stability of slope and identify the any potential risk of failure. Now, the next point is what are the two main types of slope stability analysis method? So the finite and the okay, that's only I think so limit equilibrium method and the finite element method are the two main type of slope stability analysis method which we perform across the slope. Now, the next question is that what is the difference between the limit equilibrium method and the finite element method? Yes, we have seen the definition of the limit equilibrium method and finite element method. With the definition only we clear this concept. Over here we see the limit equilibrium method involves calculating the forces driving instability and forces resulting in instability, while in the finite element method involves discretization of slopes into the means of elements and then calculating the stresses and strains in each of the element. As in the finite element, the particles are divided into small components and analysis is performed for each and every element in order to gain the output, gain the result to reach at a outcome for the same. So that is performed in the finite element analysis. Right? Okay. So with this, I think so we could sum up the today's session. Okay, one or two more problem I think we can take as the time is there with us. I will take one or two additional problem. Okay, we are here. One more question is there. This is one of the very good problem which is asked in the examination and its concept we have read today only. So answering this problem is not much difficult for you. So over here the question says that for a trial slip circle shown in the figure, calculate the factor of safety given the weight of the soil as 346 kilonewton per meter and unit weight of soil is 19 C is 20 kilonewton. So you read a relation to calculate the factor of safety for the same equal to C into summation of C plus summation of n tan phi divided upon summation of W into what? Right. So over here, the value of C is mentioned as 20. So you use value as 20 plus summation of n. N is not mentioned over here. Okay, no problem. So summation of n tan phi is 0 for the case. Assume phi equal to 0. But now summation of W into R. This is not gamma. This is R. So W is 346 kilonewton per meter. Or yeah, C into L, C into L, C into L. So this multiplied by L is nothing but R theta and R is 9, right? And theta is 70. So 70 is converted into radian, right? So if you want to convert it in radian, we multiplied it by pi upon 180. This is pi. You not only see the writing thing, okay, I'm writing from mouse, so pi by 180, 3.14 that is. And then summation of W into R, that is 346 multiplied by radius 9. When you do this calculation, you are able to get the factor of safety, F O S, factor of safety, which is found as 1.144. 1.144 is our answer. You do the calculation at your calculator, and when you perform the calculation, over here you also see C into L into R by summation of WX, but it has taken. Over here you can see, right? So C20 L is R theta multiplied by R. Okay, something maybe I have written one R maybe missing. So you see this calculation only, and Cu is 20 kilonewton per meter square is given. So C is found. Now L equal to R theta. So R is given as 9. So we have taken the R, and theta is also known to us, that is 70 degree. Okay. So by this we are able to find the L, and subsequently we are able to get the value of L. As the value of L is known, we know use this relation and get the factor of safety as 1.144, which is going to be our answer. Right. Now see the next question, which is subsequently going to be our last problem for this session. We then afterwards we will meet in the next case session, which is the regular session, which is going to take place on next Saturday. And over there we will sum up the class. Okay. So see, the question states that the problem of the slope stability analysis, assuming the circular slip surface and considering the equilibrium of the free body as a whole, is statically determinate. So true. This is the true for this given thing. Okay. Now here some reference are mentioned for you, so you can go across these books. And apart from that, the many reference books are also suggested in the course as well. So you can follow those books as well. I have used these books to create the contents and the of this presentation only. So you can go across those books and things, and so that you can develop a specific idea about the content which we have gone across. And I will suggest you to at least solve some problem what we have discussed today also. I am going to give some more problem, going to solve some more problem in the next class at the end of the next session. Specifically, I will keep 30 to 45 minutes to solve the problem of the slope stability only at the next class, but which is going to take place on Saturday from 3 to 5 only. So over there we will sum up the things related to the problems. But by then I will suggest you to solve the problems of the slope stability. Whatever the book you have, if the reference books are there, mentioned, you can use those books and you can solve the problem. Okay, thank you everyone for attending the session. I will see you on Saturday next week. Uh, Wish you a very good day. Thank you very much.